In this podcast episode, Dr. Ronald Mallett, a prominent theoretical physicist, discusses the fascinating concept of time travel, particularly focusing on the scientific principles that could potentially allow for the construction of a time machine. Throughout the conversation, Dr. Mallett delves into various topics, ranging from the foundational theories of relativity to the implications of time travel on human existence. Dr. Mallett begins by emphasizing that time travel is not merely a figment of science fiction, but is grounded in solid physics. He explains that while time travel to the future has been experimentally demonstrated, time travel to the past remains a theoretical possibility. The core of this discussion is rooted in Einstein's theories of relativity, which fundamentally changed our understanding of time and space. Dr. Mallett highlights that Einstein's work laid the groundwork for the scientific exploration of time travel, making it a legitimate area of inquiry for physicists. The conversation shifts to the implications of time travel, particularly the idea that moving through space at high speeds can slow down time. Dr. Mallett illustrates this concept using examples from particle physics, where particles in accelerators exhibit longer lifetimes when traveling at high speeds. This phenomenon demonstrates that time is not a constant, but can be manipulated based on velocity, a principle that underpins the potential for future time travel. Dr. Mallett elaborates on Einstein's theories, particularly the special theory of relativity, which posits that the speed of light is the ultimate speed limit in the universe. He explains that when light is emitted from a moving source, its speed remains constant regardless of the motion of the source. This counterintuitive result led Einstein to conclude that time must slow down for objects moving at high speeds to maintain the constancy of light's speed. This foundational principle is crucial for understanding how time travel could theoretically work. The discussion then transitions to Einstein's general theory of relativity, which introduces the concept of gravity as a curvature of spacetime. Dr. Mallett explains that massive objects, like planets and stars, warp the fabric of spacetime around them, affecting the flow of time. This understanding of gravity as a geometric property of spacetime opens up new avenues for exploring time travel, particularly through the manipulation of gravitational fields. Dr. Mallett provides compelling examples of experimental evidence supporting the theory of time dilation. He references experiments conducted with atomic clocks on airplanes, which demonstrated that clocks on fast-moving jets run slower than those on the ground. This real-world application of Einstein's theories illustrates that time dilation is not just a theoretical concept, but a measurable phenomenon. He also discusses the implications of time dilation for astronauts traveling at high speeds in space. If astronauts were to embark on a journey close to the speed of light, they could return to Earth having aged only a few years, while decades or even centuries pass on Earth. This scenario highlights the profound effects of relativistic physics on our understanding of time and aging, raising intriguing questions about the nature of human experience. While time travel to the future is theoretically feasible, Dr. Mallett emphasizes the challenges associated with traveling to the past. He explains that, according to current understanding, moving backward in time would require the creation of closed time-like curves, a concept derived from general relativity. These curves would allow for the possibility of returning to an earlier point in time, but the practical realization of such a phenomenon remains elusive. Dr. Mallett discusses the potential implications of time travel to the past, including the famous grandfather paradox, which raises questions about causality and the nature of reality. If one were to travel back in time and alter a significant event, such as preventing their grandfather from meeting their grandmother, it could create a paradox where the time traveler would never have existed. This conundrum illustrates the complexities and philosophical dilemmas associated with the concept of time travel. The conversation shifts to the role of gravity in time travel, particularly how it can affect the flow of time. Dr. Mallett explains that stronger gravitational fields can slow down time, a phenomenon that has been experimentally verified through observations of clocks at different altitudes. This understanding of gravity's influence on time is crucial for exploring the potential for time travel, as it suggests that manipulating gravitational fields could be a key component in creating a time machine. Dr. Mallett also discusses the concept of black holes and their relationship to time travel. He explains that black holes, which are regions of space where gravity is so strong that nothing can escape, could theoretically create conditions conducive to time travel. The warping of space-time around a black hole could allow for the existence of closed time-like curves, providing a potential pathway for traveling back in time. Dr. Mallett outlines his theoretical approach to building a time machine, which involves the use of a ring laser. He explains that a circulating beam of light could create a twisting of space-time, potentially allowing for the manipulation of time. This concept is rooted in Einstein's equations and represents a novel approach to exploring the feasibility of time travel. He emphasizes that while the mathematical foundation for this idea exists, the practical realization of a time machine would require significant advancements in technology and energy production. Dr. Mallett acknowledges the challenges associated with harnessing the necessary energy to create the conditions for time travel, but he remains optimistic about the potential for future breakthroughs. The discussion also touches on the intersection of quantum mechanics and time travel. Dr. Mallett explains that quantum mechanics introduces a level of complexity to the understanding of time and causality. He discusses the many worlds interpretation of quantum mechanics, which posits that every decision creates a branching of realities, leading to parallel universes. This concept could provide a framework for understanding how time travel might work without creating paradoxes. Dr. Mallett suggests that if time travel were possible, it could lead to the creation of alternate timelines, where changes made in the past would result in new realities rather than altering the original timeline. This idea aligns with the many worlds interpretation, offering a potential resolution to the paradoxes associated with time travel. As the conversation progresses, Dr. Mallett delves into the philosophical implications of time travel. He raises questions about the nature of free will and determinism, particularly in the context of parallel universes. If every decision creates a new timeline, what does that mean for the concept of free will? Dr. Mallett encourages listeners to consider the broader implications of time travel on human existence and our understanding of reality. He also discusses the ethical considerations surrounding time travel, particularly the potential consequences of altering past events. If individuals had the ability to change their own histories or the course of human events, it could lead to unforeseen consequences that might not align with the greater good. Dr. Mallett emphasizes the importance of careful consideration and regulation if time travel were to become a reality. Dr. Mallett highlights the role of technology in advancing the understanding and potential realization of time travel. He discusses the importance of funding and investment in scientific research, particularly in areas that may not have immediate practical applications. He argues that breakthroughs often come from exploratory research, and society should be willing to invest in the pursuit of knowledge, even if the outcomes are uncertain. He draws parallels between historical advancements in technology and the current state of research in time travel. Just as early pioneers in aviation faced skepticism and challenges, modern physicists must navigate similar obstacles in their quest to understand the nature of time and space. Dr. Mallett remains hopeful that continued investment in scientific inquiry will lead to new discoveries and innovations. Looking ahead, Dr. Mallett expresses optimism about the future of time travel research. He believes that as technology continues to evolve, the possibility of building a time machine may become more attainable. He encourages young scientists and researchers to explore the field of theoretical physics and contribute to the ongoing dialogue about time travel and its implications. Dr. Mallett also emphasizes the importance of collaboration and interdisciplinary approaches in advancing scientific understanding. He believes that by bringing together experts from various fields, including physics, engineering, and philosophy, researchers can develop innovative solutions to the challenges associated with time travel. As the conversation draws to a close, Dr. Mallett reflects on the potential impact of time travel on human experience. He considers how the ability to travel through time could reshape our understanding of history, memory, and identity. If individuals could revisit their pasts or witness historical events firsthand, it could fundamentally alter the way we perceive our own lives and the world around us. Dr. Mallett emphasizes that while the prospect of time travel is exciting, it also raises important questions about the nature of reality and the consequences of our actions. He encourages listeners to approach the topic with an open mind, recognizing the complexities and nuances inherent in the exploration of time travel.